Alright, so quantum mechanical theory of the atom. Over on the left side, we're going to break the atom up into two parts. We've got an inside and an outside part. As you know, in science, we always have to have fancy names for simple concepts. So, inside part, we call the nucleus. And the outside part, we call the electron cloud. We'll actually write that down for our learning objective tomorrow because we had too much to write down today. Every atom has two parts. It's got an inside part, it's got an outside part. So we're looking at one individual atom. I've taken some piece of matter, I've broken it up into its individual particles that we call atoms, and I'm looking at one individual atom. It's got an inside part that we call the nucleus. It's got an outside part which we call the electron cloud. Now, the nucleus has two what we call subatomic particles. As we talked about earlier, submarine goes within the water. Subway goes within the ground. So subatomic means within the atom. So when we zoom in and look at one individual atom, you've got certain particles, subatomic particles, in that atom. And one of those subatomic particles are these things called protons. Protons is one subatomic particle within the atom. Another subatomic particle within the atom are neutrons. Now, both of these subatomic particles happen to be located on the inside part of the atom that we call the nucleus. On the outside part of the atom, there is only one subatomic particle, and you could probably guess what that is. Electron. Now, as I look at this piece of matter, which I know is made up of atoms, which I happen to tell you it was an element, so all the atoms are the same, and I look at this piece of matter, which is also made up of atoms, and it happens to be an element, so all the atoms are the same. We know that the atoms in here are different than the atoms in here. When you put those atoms together, when they're all the same, and they look very different. This guy's black, he's kind of a weird shape. This guy's silver colored, he's a flat shape. This guy, if I tried to hit him, it would just crush on the table. This guy is bendable. Somehow these atoms are different than these atoms within this matter. And so when we look at the structure, of the atom, the only thing that's in the atom are these particles, the protons, the neutrons, and the electrons. So the only thing that can be different is the number, or how many of these particles are in each one of those atoms. All the atoms there and all the atoms there all have an inside and they all have an outside. All the atoms there and all the atoms there all have a nucleus and they all have an electron cloud. But what's different about the atoms in the flat little bendable silver colored thing and the black little chunky thing is the number of protons, the number of neutrons, and the number of electrons. So how do we find out the number of each of those? Today, we're going to just focus on protons and electrons.
Is that right?
Protons equal to the atomic number. I'm going to abbreviate the word number and use that little sign. So please don't go through the rest of the semester confused about what the little sign means. It just means number. So equal to the atomic number. And the electrons also equal to the atomic number. Number of protons is equal to the atomic number, and the number of electrons are also equal to the atomic number. Alright, the top, that top number above the little symbol is the atomic number. And so when you look at carbon, his atomic number is 6, which means equal to the atomic number is 6, so that means I've got 6 protons. It also means that I've got 6 electrons. Those protons are in the part of the atom that we call the inside, called the nucleus, this area of space. And over here, the electrons are on the outside part of the atom that we call the electron cloud. So that means if I were to take carbon, if I were to break this piece up into its individual atoms, which I can't do, I pick up one of the atoms and I look at it, on the inside part of the atom, it would not have a little sign hanging there saying nucleus on it. You would just say, okay, that's the inside part of the atom, and you would count the little guys inside that, and there would be 6 protons in there. And floating around the outside of the atom, it wouldn't say a little sign that says this is the outside called the electron cloud. They would just be floating around this outside part of the atom, and there would be 6 electrons. But if you did that same thing with this piece of matter and broke it up into its individual atoms, and you grab the little individual atom and you look at it, this guy would look very different. This atom would be much bigger than the atom over here. Because this atom only has 6 protons on the inside, 6 electrons. This guy has 30 protons and 30 electrons. 30 protons on the inside floating around, 30 electrons on the outside floating around. A much bigger atom than the atoms of carbon. That's what identifies each element as being different, is the number of particles. They all have protons and neutrons on the inside, that's called the nucleus. They all have electrons on the outside, that's called the electron cloud, but it's the number of particles that are in there that make them different. Periodic table, you will see they already have certain columns labeled as A's and certain columns labeled as B's. Then, next to the number 2, that's above your beryllium. Yes, there's a number 2, and we're going to put an A next to that number 2 up above beryllium.
We just copy like that is on the
Yes, I think so. Let me look at that real quick. Yes, as you go across, but here's what I want you to do though, as you go across over here, you'll notice that up above boron, there is a 3 on your paper, or 13.
Yeah.
3 or 13?
13.
13. What I'd like you to do is go ahead and cross out the 1 part. Cross out the 1 part. If you have whiteout or that white sticky, you can use that. And then, so cross out the 1 and then put an A after it. So instead of a 13, it'll say 3A.
Oh, okay.
And then we'll continue on until we get to the end, which we will have a total of,
8, 9, and 10 are all B, right?
Yeah, don't worry about the B's.
Oh.
All we're doing is the A's.
Oh. Just copy.
Yep. All we're doing is A's. So 1A, 2A, 3A, 4A. And then we'll finish off finally up above helium, which was, it said 18 before, is that correct?
Yeah.
And so we'll cross out the 1 on the 18 and
that?
change it to an A after it, so it'll say 8A. So 1A, 2A, 3A, 4A, 5A, 6A, 7A, and then 8A. We don't need to worry about labeling the B's or anything like that, just the A columns right now. Then, up at the top, I want you to find where it says important constants. Important constants. And we're going to put this next to, I'm going to write mine down here, but I want you to write yours next to where it says important constant. I want you to put in quotation marks, A column equals, A column equals number, and then in parentheses the abbreviation. Number of electrons. And in this class, most of the time when I refer to electrons, I will put an E with a negative just as a shortcut so I don't have to write out the whole word electrons. Just put an E with a negative. Number of electrons available for bonding. And the words we've been using interchangeably with bonding is like sticking to or connecting with. Number of electrons available for bonding.